right, so periodic graphs and phase shifts. We looked yesterday at using these two functions, a sine of bt and a cosine of bt. And we learned how the constants a and b affect amplitudes and periods. And so we then have, here's our general rule, which is a tad bit different than what we've been using. But, you know, we can look at it anyway and just be able to understand what those letters affect. So in this case, A is going to affect the stretching, so it's a vertical stretch or compression. B is going to be our horizontal stretch and compression. A form of this with C is going to be our horizontal shift, and we'll talk about that a little bit more. And then D is going to be our vertical shift, so whether we move it up or down. So first of all, looking at vertical shifts then, if we recall from back in section 3.4 that if we add a constant to the rule of function, all it does is move the graph vertically either up or down. So here we're going to work with a little bit different. We have the -3 sine of t minus 4. So we want to describe what happens here and then graph it on the interval from -2 pi to 2 pi. So first of all, what happens to this graph? Okay, one thing is going to be moved down 4 units. Okay, what else? Okay, so it's vertically stretched by 3, and then what's the negative do? Okay, so we're going to reflect it across the x-axis. So that's vertical. And we're going to stretch it vertically. By a factor of 3. And then we're going to move it down 4. All right, so let's, I'm going to sketch the graph of sine first of all and use that to be able to, let's go green and, all right. Oh, no, we click it for the key. So here's the graph of sine. Remember our graph of sine, so we're at 0, 1, 0, -1, 0, and so on. All right, so the graph of sine is here. It's nice and neon. So to do the graph of this, right, what's changing? Are we changing any x values? No, okay, we have no horizontal shift, no horizontal compression, nor stretch. Just the y values. So all we care about are the y values then. Okay. So here we have, so we're going to take all the y values, and what are we going to do with the y values? Okay. We're going to multiply them by -3, okay, and then what are we going to do? And then subtract 4, because those are all changes in y values. So the -3 here means I'm going to multiply them by -3, and then the -4 means I'm going to subtract 4 then. So we'll start right at the origin, okay, at 0. What's 0 times -3? And -4 is Negative 4. So this point that was at 0 is now going to be at negative 4. The one that's at positive 1. Positive 1 times negative 3 is? And negative 3 minus 4 is? Negative 7. Okay. 0, we're still going to be at negative 4. Okay. The one at negative 1. Negative 1 times negative 3 is 3, and 3 minus 4 is negative 1. And here we have another 0. Okay. So then the ones that I'm going backwards, I can do the same thing. At negative 1, it's going to be at negative 1. 0 would be at negative 4. Positive 1's at negative 7. And back to 0. And so we have this graph. So there's the graph of negative 3 sine of t minus 4. Okay. Phase shift. Phase shift is our horizontal shift. So that's going to be our movement horizontally. So we're going to look at, says, so we're switching x and y, so I was looking at the opposite. Okay? So we're going to rewrite every function we use, and we're going to look at this a little bit more in this form here. Okay? So it says a sine of b times the quantity t plus c over b plus d. Okay? So our actual, so the value of a then is going to tell us our horizontal or our vertical stretch and compression. B tells us horizontally whether it stretches or compresses. Okay? Remember, that's the reciprocal. This C over B, that's going to tell us our horizontal shift then. Does it move left or right? And of course, there's our D again for our vertical shift. So whenever I have a function, then I want to see it in that form. So that if we do have a value of b, it's factored out. Okay? It can't be, we're not going to leave it in this form here. Okay? We're going to factor the b out. Okay? So it helps us to see what the horizontal shift is. Okay? Now in these two examples, right, it's already there. All right? There is no value of b, so or I should say the value of b is 1. So we want to describe these graphs. Right? So letter A, what happens with that graph there? Okay, it's a horizontal shift, 3 pi over 4 to the right. Okay. And what about B? Okay, so it's a horizontal shift, pi over 4 units to the left. So which means then that I would take my zeros and my maximins and move them over that far. Okay, and I redraw the graph. Because the one thing is the sine and cosine graphs always are going to look the same. It's just a matter of where are the points at. Okay, it might be stretched out, might be shrunk, but it's still going to look that way.
So then what do you do? You do have a value.
So if we have combined transformations, so we have to involve everything then. Vertical shifts, horizontal shifts, stretches, compresses horizontally and vertically. So here, first of all, I have the example from the book. Okay, this isn't the one on your paper, this is the one in the book. And it says state the amplitude, period, and phase shift. So the first thing we're going to do is rewrite it in this form. Okay? Always rewrite it in that form. And the only difference between this and what we have here is that the coefficient of t, okay, is going to be factored out. So I have to rewrite it in this form, okay? So the 3 is still there, so I have 3 sine, but the difference is I have to factor out the 2. So we have 2 times t plus what? Well, if I'm factoring out the 2, I'm dividing by 2, right? So it's 5/2. All right, and you can check that by multiplying, okay? 2 times t is 2t. 2 times 5/2 would be 5, okay? So that would work then. So if I multiply this back out, it would tell me. Okay? Now, since it's sine or cosine, it does have an amplitude, and the amplitude in this case is 3, okay? The value of A. I should say absolute value of A. Okay? The period, okay? Remember, the period is equal to 2 pi divided by the value of B. So the value of B in this case is 2. Okay? 2, so we have 2 pi divided by 2, which is pi. Okay? And the phase shift is the horizontal shift. So this is going to be shifted, what? 5/2 to the left. Okay, so the phase shift then is going to be, if it's negative, or if it's shifted to the left, it's a negative phase shift. If it's shifted to the right, it's positive. Okay, remember, amplitude is always positive because amplitude is the absolute value of A. Period is always positive. And the phase shift, if it's to the right, it's positive. If it's to the left, it's negative. Okay? Now, this is the reason why we had to graph it, or had to factor this out, is because if you look at it in this form here, up here, we can see that the phase shift is not 5, it's 5/2. All right, and so I want you to now we'll see. All right, so let's look at this other one then. Okay, so you go ahead and write that in the correct form first of all. All right, Brandy, what is it? T minus what? 4/3. Okay. All right. So when I rewrite it, I get 2 cosine of 3 times the quantity t minus 4/3. So now the amplitude is 2. The period is 2 pi over 3. All right. And the phase shift is, okay, positive 4/3. Very good. Okay. So there's your answers.